So the last question he says 10.4, if angle B2 is equal to angle E, prove that DB parallel to EA. Let me show you how. So we need to prove DB parallel to EA. Now, angle B2 is equal to angle D1. Angle B2 is equal to angle D1. Why? Because OD is a radius and the OB also radius. So that's why this angle and this gonna be equal. Angles opposite, equal sides. Now angle B2 is already given that is equal to angle E in the statement he say. So therefore we can say angle D1 is going to be equal to angle E because they are both equal to same thing and they be proved, and that's now therefore DB is going to be a parallel to EA. Why? Because corresponding angles equal. Have a look here. This one and this one corresponding angles, making F now. Have a look here. Angle D1 and angle E, they are corresponding angles. Corresponding angles are equal. So the angle B2 is equal to angle D1, angles opposite equal sides. I'm going to show you the calculation now. Angle B2 is equal to angle E is given. You already say in the statement, have a look here. There he say angle B2 is equal to angle E. Now, therefore, angle D1 is equal to angle E because they are both equal to angle B2. So we can say the angle D1 is equal to angle E. Therefore, DB parallel to EA, corresponding angles equal. That's the reason. Prove that TO is equal to TO multiply FE over AB. Now we need to prove this question. How to do it? I'm going to show you how to prove this question. But remember, these type of question you have to apply the similarity and proportionality theorem, sometimes together, sometimes separate, but sometimes most of the time along the line you already solve this question. So we're gonna utilize that calculation to prove this ratios. So we need here TO and FE and AB and DO. So first of all, I'm gonna remember earlier we proved that these two triangles are similar. So I'm gonna see if I can get the information from there. I'm gonna remember if the triangles are similar, their corresponding sides are in proportion. So I'm gonna see now what I can do there. Remember triangle TFO similar to triangle DFE we proved earlier. So the first two TF, so I'm gonna write the proportion sides now. TF over DF is equal to first two and the first two, and the last two FO over last two FE is equal to first and the last TO over again first and the last DE, and the reason is similar triangles. Now what we need to use here, so we don't need TF and DF. Why? Because according to the demand of the question we need TO, FE and AB. So we got TO times FE gonna be here, and then DE times FE obviously that's gonna equate with something, but the TF and DF we don't need at all. So I'm gonna highlight it what I need. So I highlighted what I need. So I'm gonna cross multiply now these two gonna cross multiply. DE multiply FO is equal to these two TO multiply FE. You can write either one first. So this is, I get the DE multiply FO is equal to TO multiply FE. Now I need the TO FE must be on top. Okay, TO FE must be on top. So therefore I can isolate here DE only. That's the way I can pull them up. Therefore, TO multiply FE must be on top, divide by FO. So this is my first now. I get the DE here now. Now I'm stuck here because remember we need here DO and AB. Where to get the DO and AB? We got the TOFE, but the DOAB is still missing here. So we can't get DO and FE. We can't get DO and AB here. So let's go to another triangle. Similarity we finished. Let's see if we can get something in proportionality. Remember, if there is more than one pair of triangles, you need to prove they are similar. Then you can utilize their corresponding sides. Remember, we only proved one pair of triangles that they are similar. So obviously now we need to see the second triangle. I can see the proportionality theorem gonna work here now, because most definitely we're gonna use the proportionality theorem. So now I'm gonna use the proportionality theorem here. So if I can see the in triangle OEA, remember we already proved that the EA parallel to DB. So the long parallel line AE and the short parallel line BD. So now we can apply proportionality theorem here. So we need actually AB. So the AB is here. So it's gonna be a OB over AB is equal to OD over DE. We apply the proportionality theorem here. So I must write here, this is in triangle OEA, DB parallel to EA is given, and OD is over DE is equal to OB over AB. You can write first this one and second that one, doesn't matter. They are both equal to each other. Line parallel side of triangle. This is a proportionality theorem I applied, that's why I have to give the reason. Now cross multiply, because we do need AB. So the OD multiply AB is going to be equal to OB multiply DE or ED, same thing. We need DE actually. We need to isolate the DE. So the DE I can isolate because AB must be at the bottom. So we need a DE. We already find the DE earlier, so I can get the DE also from here. Then I can equate both of these equations. So the DE is going to be OD multiply AB over OB. So therefore DE is going to be, you can write this way, DE is equal to DO or OD, same thing, multiply AB over OB. Right. So the DE is going to be equal to DO multiply AB over OB. So now you can see DE and this DE. So you can see DE is equal to TO multiply FE over FO, and this side also DE is equal to DO multiply AB over AB. So they are both equal to same thing DE. So we can therefore we can say this ratio is gonna be equal to this ratio. So we're gonna equate both of these. So which means they are both equal to each other. So DO multiply AB over OB is equal to TO multiply FE over FO. So DO must be equal to TO multiply FE over AB. So TO FE on top and AB at the bottom, and DO must be at the left hand side. So now we got the problem here. DO I can isolate, TO FE is on top is fine, but the AB I need to bring down, but these two, they are not belong to this equation here. They are not belong here. So now we need to think out of the box. So what we have to do? So we can go back to our sketch. DO is a radius, OF is a radius, OB is also a radius. So therefore DO is equal to OF OF is equal to OB. They are all equal to each other because equal radii. So I'm gonna substitute with DO multiply AB. I'm gonna substitute those sides now. This become equal to DO. Why? Because they are equal radii. I need a DO. And that's a TO multiply FE, also gonna be DO. And we give the reason DO is equal to OB and is equal to FO because equal radii. So now that's why I replace OB and FO with DO or OD, same thing. Now obviously we don't need this one. This is cancel. So we can cross multiply DO multiply AB is equal to TO multiply FE. Must remember there is nothing left here, one only cross multiply. So we need DO. DO must be equal to TO multiply FE. So the both side we divide by AB. There we go. So we proved DO is equal to TO multiply FE over AB. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.